Greetings and welcome to the introduction to astronomy. In this lecture, we are going to look at large impacts on Earth, especially concentrating on Earth. And we will look at some more of these later on in the course as well. But we want to go ahead and get started with them here as we're talking about Earth itself. So what is the evidence that Earth has been impacted by objects from space? Well, we have nearly 200 craters that have been confirmed, and these are at least 100 meters in size. So why do we see so few when we see so many more on the moon? Well, there are a couple reasons. Craters are destroyed by erosion and by geological processes. So lava can fill in craters and wipe them out. And wind and water erosion can slowly erode craters. Now, while it may not seem like a lot, you can imagine taking away a millimeter a year from a crater would take away a meter over 1,000 years. Well, that still doesn't seem like a lot. But if you went to 1 million years, still just taking away 1 millimeter a year, that would wipe out a kilometer of material. So it does not take that long on Earth, even with the very slow erosional processes, to wipe out craters. Craters more than a few million years old are either very large in very dry areas, such as meteor craters shown here in Arizona, that are still able to be seen after that time. We also have one difference is that small objects do not make it through the atmosphere on Earth. So small objects which might strike our moon never strike Earth's surface. And finally, most of Earth's surface is water. So if a meteor hits in the ocean, it's going to leave a big splash. It might create a tidal wave of material if it's a massive enough impact, but it is not going to leave a scar behind in the form of a crater. So how often do these occur? Well, small meteors, we see those every single day. Those are things that burn up in the atmosphere all the time. Over decades, meteorites will strike the Earth and cause some damage. If we see some of these that break up high in the atmosphere, every dozen years, couple dozen years or so, these do occur. Now, these are not going to cause any significant damage. These break up in the atmosphere. There may be minor damage that could occur if you're relatively close to the area, but for the most part, they're not going to be a significant event. Over larger times, when we start to talk about tens of thousands of years, these are ones that can cause significant local devastation. We will look soon at the Tunguska like events and one that occurred a little over 100 years ago. But these are even larger, and these only occur every tens of thousands of years and could cause significant disruption to a regional area, but do not really affect things that much globally. Now, when we get the very large ones, when we get to the millions of hundreds of millions of years time, then we get the extinction class events. And those are the ones that can wipe out large percentages of the existing species on Earth. Fortunately, again, those only occur every 100 million years or so. But they still have happened in the past. And we will look at some of the evidence for that coming up. But let's first look at some of the smaller ones. This is the Tunguska event. And this is an image from Siberia in 1908. And an object was seen that exploded about 5 miles above Earth's surface. So you have to imagine this is an object coming in at very high speed from space, a lot of friction with the atmosphere, and eventually that friction just became too much for it and it tore itself apart. That massive explosion flattened 1,000 square kilometers of forest. Now here we see some of those trees lying down. How can we put that into perspective as to how much that is? Well, here's the same zone of destruction around Washington, D.C. So District of Columbia here in the square, the beltway around it, the highways going around it. And we see again a much larger area. So something like this to occur would cause significant localized damage to that area. Now, of course, the odds of it happening directly over a city would be pretty small, but it could still cause some pretty significant devastation to that region. Now we could also look at larger ones, and let's look at the Yucatan event. This was a lot longer. This was 65 million years ago, and you may have heard of that one as the causing the extinction of the dinosaurs. We can see the remnants of that crater still off the Yucatan Peninsula in Mexico. So impact point right about here. And then we can see the remnants of this when we look at this around. We can kind of trace it around what is still visible on land. The rest is buried beneath the ocean. So we can still see remnants of the crater. Now this was a much larger impact. I mean, this is one of those extinction level events. So let's take a look at this by comparison as we did with the previous one. Well, instead of just being the size of the Washington, D.C. area, this impact, this is the inner crater of the impact, would cover not only Washington, D.C., but Baltimore and much of the surrounding area. So much larger area than the previous, the much smaller one that occurred in Siberia that we looked at previously. So a bigger object causes much more devastation locally, here wiping out two cities completely and causing significant devastation. Even areas are significantly away from that were it to occur over the middle. And of course, also causing global effects as well. And this leads us to things like the mass extinctions. How do we get a mass extinction? Well, about 5 times. This has occurred about 5 times in the last 500 million years. So in 500 million years, about 5 times. That's what we say, about 100 million times each time. So what is the evidence for this? This is the most recent one about 65 million years ago, which we talk of as the dinosaur extinction. And what is the evidence for this? Well, we see the crater that we previously discussed off the Yucatan Peninsula in Mexico. We also see a layer in the crust of iridium. Now iridium, here we see in the layer in the middle here, is enriched in that. And that area can be dated back 65 million years. And it's very interesting because iridium is very rare in Earth's crust, but it is very common in meteorites. So a massive impact could have thrown a lot of iridium into the air and could have then enriched this region. Now this is not to say that this is all iridium. What that means is that it has a higher concentration of iridium than either the soil rocks below and the rocks above, that this region is higher in that element. Now that does not, what that shows is that gives us two pieces of evidence. A third one I don't mention here is that we also find that the dinosaur fossils exist below this layer and not above it. So it also ties into the timing of the extinction of the dinosaurs. So how about, we've seen that these can occur at various ranges. What about future impacts? Well, very simply, yes, they will occur. We can never say when because it is a probability. It's not an exact when as to when they will strike us, but eventually it will happen. Now we said they happen about every 100 million years, and the last one was 65 million years ago. So it sounds like we got 35 million years to go before an extinction level event would occur. However, it's not guaranteed that it will wait exactly at that 100 million year mark. It could happen in a year, a decade from now, a century, a millennium, or it could be millions of years from now. It could be longer. It could be another 50 or 100 million years from now. We do know lots of objects, thousands of them, that cross Earth's orbit. These are all ones that could strike Earth. Now we look at the sizes of them and what we've detected, and we've been working on trying to detect the larger ones. But the problem is these are all small. They're very dark. They don't reflect a lot of light, making them difficult to be able to detect. And there are really lots more that we have yet to be able to find. Now you can see that back in 1980, we knew of hardly any. In 1990, we still knew of hardly any. By 2000, we had started the search a little bit more and the numbers had increased. And By 2010 and here into about 2015 at the end of this chart, we had started to find now 10,000 of them that are large. Now note how big these are. The red ones are at least a kilometer. So those in the red with 1 kilometer or more are the ones that can cause significant damage. Those are the ones that could cause a global event. Those are the much larger ones. And you can see it looks like we probably found most of those. That doesn't mean we found all of them. But you notice that as we started detecting them here in the 1990s, the level seems to have leveled off. We seem to have a pretty good count of them and we're not finding more and more. However, things that are only at least 140 meters, so more than the size of a football field, are still increasing and we're still finding those at a very rapid rate. So the number is increasing drastically. And if we look at all sizes, even smaller than that, it's increasing even more. Now, of course, the tiniest ones are not a big danger to us unless you happen to be right under it. 140 meters, that's a pretty significant impact and will have some serious effects. And the larger ones, of course, are the most damage. The difficulty with a lot of these is being able to track their orbits accurately. Orbits are constantly changing because there are gravitational interactions between objects that cause these objects to deviate a little bit. So they may be not going exactly the way we thought they were. So it's difficult to predict exactly what will happen to it and in 50 or 100 or 1,000 years after a number of orbits where it may have passed somewhat close to a planet or to another asteroid that could have caused a deviation in its orbit. So studies are continuing to track these and try to look at methods to be able to eventually divert them if they were found to be coming to Earth. So let's go ahead and finish up with our summary. And what we've looked at is, yes, the Earth has been impacted by objects in the past and it will be impacted again in the future. The larger the impact, the less frequent, but the more devastation that occurs. And the massive impacts, including the largest ones, can cause mass extinctions here on Earth and have done so multiple times in the past. So that concludes this lecture on large impacts. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.